Now that we know about mean, median, and mode as measures of central tendency, and range and interquartile range as measures of spread, I want to talk about how those five measures will change if we make modifications to our data set, because this should give us a good intuitive idea of how those measures reflect changes in the data. Now, there are two ways that we can make modifications to our data set. One is called shifting, the other one is called scaling, and I want to start by talking about shifting. Shifting is what happens when we either add a value or subtract a value from every point in our data set. So, for example, let's say we have the data set 3, 3, 7, 9, and 13. So just a 5-point data set. We could calculate our mean, median, mode, range, and interquartile range for that data set. So, for example, the mean would be 3 plus 3 is 6, plus 7 is 13, plus 9 is 22, plus 13 is 35, and we have 5 total data points, so 35 divided by 5 is a mean of 7. The median, we can see our data is already listed in ascending order from smallest to largest, so we can see that the middle number is 7, the median will be 7. And then the mode, we can see that 3, the value 3, occurs more in our data set than any other. 7, 9, and 13 all occur one time, but 3 occurs twice. So the mode of the data set is 3. The range, remember, is the largest value minus the smallest value. So 13 minus 3 is 10. And the interquartile range we could find if we do a little manipulation here. So we know that the median is 7, which means that to find the median of the lower half of the data, the lower half being 3 and 3, the interquartile range will be the mean of 3 and 3, which is just 3. And the median of the upper half of the data, so the upper half is 9 and 13, the median of 9 and 13 is going to be the value in between here, which is the mean of 9 and 13. So the mean of 9 and 13, 9 plus 13 is 22. 22 divided by 2 data points is 11. So we get 11 for the top half, 3 for the bottom half. So 11 minus 3 will be 8. So the interquartile range is 8. Now remember we said for shifting that we would be adding a value or taking a value away from every data point in the set. So for example, I could choose to add 6 to every data point in my set. That's just an arbitrary number I picked. I could choose to add any value or subtract any value. Let's just say I'm going to add 6 because I want to know what happens to my data when I add 6 to every value. So then my new data set will be this. 3 plus 6 is 9, 3 plus 6 is 9, 7 plus 6 is 13, 9 plus 6 is 15, and 13 plus 6 is 19. So I've shifted my entire data set by a positive constant, 6, and this is then my new data set. So if we calculate the same mean, median, mode, range, IQR for my new data set, here's what happens. The mean is going to be 9 plus 9 is 18, plus 13 is 31, plus 15 is 46, plus 19 is 65. When I divide 65 by the number of data points I have, 5, I get 13. So the mean is 13. The median, I can already see, is my middle value right here. So the median is 13. The mode is the value that occurs most often. That's going to be 9. The range is the largest value minus the smallest value. 19 minus 9 is 10. And the interquartile range, we already have the median. We look at the upper half of the data, 15 and 19. We need to find the median of 15 and 19. Well, that's going to be the mean of 15 and 19. So 15 plus 19 is 34. 34 divided by 2 is 17. So I get 17 for the upper half. And then the mean of 9 and 9 is 9. That's the median for the lower half. So 17 minus 9 is going to be 8. So in order to shift our data set, we added 6 to get from the original data set to the second data set. And look what happened. Our mean we added 6 to get the new mean. We added 6 to get the new median, so 7 plus 6 is 13, 7 plus 6 is 13. And we added 6 to the mode to get the new mode of 9. In other words, the mean, median, and mode all changed in the same way that we changed the data set. So we added 6, which means to find the new value of the mean, median, and mode, we also have to add 6. But the range and interquartile range stayed exactly the same. And that should make sense to us because the mean, median, and mode are all measures of the middle, and we've taken this whole data set and shifted it up or shifted it to the right on the number line, so the middle is going to change. But the spread of the data set stays the same. We just move the whole group of data up together, so the range is going to stay the same. The interquartile range is also going to stay the same. So the punchline is what I already had written here, that when we shift the data set either by adding a constant like we did here with plus 6, or by subtracting a constant, in both cases, the mean, median, and mode will change by that same constant value, but the range and the interquartile range will stay the same. Now, what about if we multiply or divide our data set by some constant value? So here we added 6, but what if, for example, we multiplied everything by 2? Well, this time I'll give you the punchline up front. This is called scaling, when we multiply or divide by a constant. And when we do that, we're going to get all 5 measures, mean, median, and mode, and range and IQR, to change by that same constant value. So if we multiply the entire data set by 2, that means we're also going to multiply the mean, median, mode, range, and IQR by 2. If we were to divide the entire data set by 4, that means we would divide the mean, median, mode, range, and IQR by 4 to get the new mean, median, mode, range, and IQR. If we want to prove it, let's take again the same data set, 3, 3, 7, 9, 13. We already know that the mean, median, mode, range, and IQR are 7, 7, 3, 10, and 8. Let's say we want to multiply by 2 to get our new data set. So we're going to multiply by 2. Our new data set will be 3 times 2 is 6, 3 times 2 is 6, 7 times 2 is 14, 9 times 2 is 18, and 13 times 2 is 26. So we have our new data set. Now let's quickly calculate those new values. So for the mean, if we add these together, 6 plus 6 is 12, 12 plus 14 is 26, 26 plus 18 is 44, and 44 plus 26 is 70. 70 divided by the number of data points 5 is 14. So we get a value for the new mean of 14. The median, we can see here, is still the middle number, so the median is still going to be 14. The mode of the data set, 6 occurs more often than any other value, so the mode is going to be 6. The range will be the largest value, 26, minus the smallest value of 6. 26 minus 6 is 20. And the interquartile range, again, because we have just 2 data points on the left here, we'll find the mean of 6 and 6. That's going to be 6. And then the mean of 18 and 26 is 22. So 22 minus 6 gives us 16. And what we can see happened here, when we multiplied the data set by 2, we multiplied the mean by 2 to get the new mean. We multiplied the median by 2 to get the new median. We multiplied the mode by 2 to get the new mode. And the range and IQR got multiplied by 2 as well to get the new range and new IQR. So to summarize, we can say that when we shift the data, the mean, median, and mode change, but the range and IQR stay the same. And when we scale the data, meaning multiply or divide, the mean, median, mode, range, and IQR all change. The last thing we want to talk about in this video are outliers. And outliers are values in the data set that are much higher or much lower than any of the other values. So let's take an easy example and pretend that we have the data set 1, 2, 3, 1,000. So we have 4 points in our data set. And what we can say is that 1,000 is clearly an outlier. So if we were to graph this on a number line, what we would see is that the bulk of our data, 3 out of the 4 values, are clustered right here around 1, 2, 3. They're all together. And then way, 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 way out to the right, we have this data point, 1000, all by itself. So it's an outlier. It lies way outside of the rest of the data all by itself. What we want to do is use this outlier to show the effect on the mean and the median, and to prove that the median is more resistant to change than the mean is. So here's what we mean. Let's pretend for a second that we actually only have the data set 1, 2, 3. 1000 is not included in that data set. So if we just have 1, 2, and 3, and we want to calculate mean and median, here's what we get. The mean will be 1 plus 2 is 3, 3 plus 3 is 6, 6 divided by 3 terms, so 6 divided by 3 is going to be equal to 2. So the mean of the data set is 2. The median of the data set is also 2, so we already have our data set listed in ascending order from smallest to largest, and the middle number is 2. So the median will also be 2. Now, if we suddenly expand our data set to include the 1, 2, 3, and the 1000, so now we have all 4 terms in our data set, what do you think is going to happen to the mean versus what do you think is going to happen to the median? Well, it'll become obvious pretty quickly. If we calculate the new mean, so we have here the new mean, we got 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 1000 is 1006. So the sum of the terms is 1006. And then we have 4 terms in the data set, so we want to divide that by 4. Well, 1006 divided by 4 is approximately equal to 252. It's right about that. The median of the new data set, on the other hand, so the median of the new data set, we have our terms listed in ascending order, 1, 2, 3, 1000. So the middle number, let's see, 1 and 1000 are on the ends, then 2 and 3. So the median is going to be right here between 2 and 3, which means that in order to find the median, we need to take the mean of 2 and 3. Well, the mean of 2 and 3, let's see, 2 plus 3 is 5. So 5 divided by 2 terms is equal to 2.5 or 2.5. So look what happened. We added this huge outlier above the data set, so a number that was much larger than the rest of the data. And the median barely changed. The original median was 2, the new median is 2.5. It's almost the same thing. The mean, on the other hand, went from 2 all the way up to 252. These are totally different means. Adding the 1000 outlier totally skewed the mean and pulled it all the way up from 2 to 252. And that should make some intuitive sense to us, because when we look at this data set, we can tell just by looking at it that the 1000 is really going to pull up the mean way above the 1, 2, and 3. But the median, because we're still just talking about the middle number in the data, we could have a huge outlier or even 2 huge outliers way above the data set or 2 huge outliers below the data set, and the median might barely change because it's still just this number right here in the middle. So the way that we describe what's happening here is that we say that the median is much more resistant to change than the mean. So it's much, much harder to move the median. The median is much more likely to stay steady, stay around its original value than the mean is. It doesn't take much at all. We can just add 1 data point and totally throw the mean off to make it something way different than it was originally. So the mean is very easy to change. The median is much more difficult to change. So we say that the median is more resistant to change. And then regarding outliers, we want to take away this idea that if we add an outlier way above the data set, then it's going to skew the mean up higher than it would normally be without the outlier, and the mean will change more than the median. If we add a data point way below the data set, for example, let's say our data set instead were 98, 99, 99, and then we went and added the outlier 1 way below the data set, that's going to pull the mean down drastically. The mean's going to go from something around 98, 99 way down closer to 1, but the median will stay very similar. And then the same would be true in the opposite case. If we start with a data set like this, 1, 98, 99, 99, and we eliminate an outlier, so we get rid here of this 1, and now we just have 98, 99, 99, that will let the mean come back up to be much closer to this tightly clustered group of data. So again, the mean will move a lot and move up much higher. The median, again, will retain its original value much more closely versus the mean will jump a lot. So overall, we're just saying that adding or removing a high outlier, an outlier that's way above the data, or adding or removing a low outlier, an outlier that's way below the data, is going to shift the mean much more than it will shift the median.